Yeah.
Okay, so today basically we do SPM 2022 paper one. Okay, I will do the 40 questions with you all. And then next week I will do the paper two lah. And next week I do paper two, question 1 to 11. Okay. So I do paper one first. Last week because I want to take my time to rest, a bit lazy. Okay, so I come back this time. Okay. So yeah, you straight away jump into question one for this objective. Okay. So actually, SPM 2022 is a bit challenging. Okay, for objective questions. So let's straight away look into that. Okay. So diagram one shows the curve of change in the state of matter for solid X. So they're asking about solid X. Okay. If you see the graph like this means heating lah. You notice heating already because the temperature increases from P degrees Celsius to S. Okay. So this one is heating. Okay. So heating of solid. Heating of solid means of course, after you heat the solid, normally solid will turn to liquid. Yeah. Okay. Of course, this process is called melting. Okay. This process is called melting. Okay. So what is the physical state of X and point Y from Q to R? Okay. So of course, P to Q, when the temperature increases, is solid. By the way, this is form 4, chapter 2. Okay. So R to S is liquid. Then Q to R, the temperature is constant. This is this time. eh, This is the time where the temperature constant, where the state changes from solid to liquid. Solid is on the way to liquid. So it's why it can be half solid with half liquid. Okay, not exactly half, but depends on time. Okay, of course, beginning we will have more solid. At the end, you have more liquid. So the answer between Q to R, is solid and liquid. Point Y is the melting point. So the answer is C. Okay. And then we have question 2. Which of the following is correct match of each substance and its type of particles? This one is also form 4, chapter 2. Okay, so this one is, okay, we got paracetamol, detergent, and weather balloon gas. Okay, so in this case, paracetamol, if you see this kind of medicine normally, okay, which you will learn in form 5, chapter 5, okay, in 5.4 modern medicine, normally you know this is molecule. Okay, you know that less like even like vitamin C, formula of vitamin C, paracetamol, all this, okay, is a molecule. Detergent normally is ion. Okay, it's ion because got charge. I told you right. You learn detergent, it has hydrophilic head. So you got SO3 negative and Na plus. Okay, so contain ions. Okay, contain charge. Okay, weather balloon gas. Okay, this one is talking about the helium, function of helium, group 18, which is an atom. Okay, so the only answer should be A. Okay. Okay. So, and then we have question 3. Okay, diagram 2 shows the use of substance X. Okay. So in this case, it shows you the pencil. Okay, the X part. Of course, pencil made by the lead. Okay. So the pencil lead is made by we call it graphite. X graphite. X graphite. Okay, this question is a bit interesting. Okay, so it's a bit like Form 4, Chapter 5. Okay, it's a bit like Form 4, Chapter 5 about the boiling point, melting point. Okay, so they ask you which one can conduct electricity, all this. Okay, but actually it's a bit like Form 4 Chapter 2. Okay, but this part is a bit extra question that you have never seen before. Okay, so actually graphite weapon is now there are a few things like graphite, graphene, and diamond. All this made by carbon. Okay, but the problem is, as you know, the diamond you learn in Form 4 Chapter 5, diamond is having a very high melting point and boiling point. Okay, meaning diamond very hard to get melted. Okay, because why? Because diamond, you see, diamond contain all the carbons, right? Made by carbons. Okay, so if carbon made by carbon, right? I mean diamond made by carbon, right? In this case, as you know, carbon normally you will have normally carbon you have like uh electron arrangement 2.4 means carbon will share 4 electrons in this case. Okay, but the funny thing is for normal diamond, normal graphene, okay, it does not contain any delocalized electron. Okay, because all the 4 bonds connected all are strong covalent bond. Okay, all the strong covalent bond. Okay, let's say we talk about diamond. Okay, but graphite had a similar structure, but there is one of them, one of the bond that related to connected to delocalized electron. And that's the difference. Okay, connected to delocalized electron. Okay, so in this case, where actually it makes them, okay, you see, diamond cannot conduct electricity, okay, because no charge, no electron, no ion, nothing, okay. But graphite, interestingly, can conduct electricity because it has the free moving delocalized electron. Okay, so A cannot be the answer, but it still contain it's still a covalent compound. It's still a covalent compound. Okay, graphite is a covalent compound. Okay, but it's just that one of the bond used to bond with the delocalized electron. Okay, so that's why the correct answer is B. Okay, it has low melting point, boiling point. Yes, this is one of the property for for covalent compound. Okay, but supposedly A also correct if it is diamond, if it is like graphite, graphene. But graphite is different. Okay, because your pencil made by graphite. Okay, so C is not isotope for X. No. Okay, so used to detect underground pipe leakage underground. This is sodium 24. Nothing to do with the carbon 12. Okay, nothing to do with carbon. Okay, used as standard atom to determine the relative atomic mass of an element. It is not. Okay, so if wait, okay, so the best answer will be B lah, in this case. Yeah. Actually, donkey also can lah. Okay, but it's not the main purpose. Okay, so the main purpose here is to make the pencil the pencil lead. Okay, actually donkey also quite close answer. Yeah, this question is a bit tricky. Okay, so but because it's not like singular atom, okay, so this one is contain the whole picture. This one is like carbon 12 is like only one atom if it's for donkey. Okay. So, but this one is the whole structure of graphite. It's not talking about one carbon 12. Yeah. Okay. Okay, it's an interesting question for question 3. Okay, so question 4. Hi, Sharina. Okay, so in this case, this one is from 4 chapter 3. Okay, so when Ahmad carried out an experiment by adding potassium iodide solution, which is the Ki, to lead-2 nitrate solution. Okay, a yellow precipitate form. This one, if you know, you learn Form 4 Chapter 6, we talk about this, okay, where the iodide ion from Ki will find lead-2 ion from lead nitrate. Okay, Pb2 plus attract I minus to form PbI2, which is a yellow precipitate. Yeah, which is the yellow color precipitate. And then we have, they told you, right? Yellow precipitate. And of course, the other one is the colorless solution, the soluble salt. The yellow precipitate is the insoluble salt. Okay, so which is here is K plus you attract NO3 1 minus. That's why you get KNO3 times 2 for KNO3 times 2 for Ki. So in this case, they ask which one is the correct statement. Okay, to describe the experiment. So you just check this one. You have to spend time to check one by one. Okay, so in this case, A, 1 mole of potassium iodide react with 1 mole of lead-2 nitrate to produce 1 mole of lead-2 iodide and 1 mole of potassium nitrate. Wrong. Okay, in this case, that's why I told you to write down the equation important, because it's not everything 1, 1, 1. Okay, it looks like correct, but the thing is the number is wrong. Okay, because you have to balance times 2 here, times 2 for Ki, times 2 for KNO3. So it means you have to change this to 2 mole, right? And you have to change to 2 mole of KNO3. Yeah, so definitely A is wrong. B, 1 mole of potassium iodide, wrong. Out already. Okay, immediately out. C, okay, 2 mole, okay, correct. 2 mole of potassium iodide. Okay, react with 1 mole of lead-2 nitrate. Correct, 1 mole nitrate. To produce 1 mole of lead-2 iodide. Correct. And 2 mole of potassium iodide. Correct. So answer is C. So it's like this one is just, you have to write the equation and balance. That's it. Yeah. And donkey, wrong in the lead-2 iodide. 2 mole supposed to be 1. Okay. This one is just about the writing equation and balancing. And read through the sentence with words. Okay. So yeah. And then you look at question 5. This one is Form 4 Chapter 2. Okay. Form 4 Chapter 4. Which pair is correctly matched? Okay. So argon used in lasers to treat eye retina. The eye retina one is not argon. Okay. It's krypton. Okay. In group 18, you got six main different monoatomic gas. Okay, we have helium, neon, argon, krypton, xenon, radon. Okay, agak tahu. Okay, so helium used to make weather balloons and also in scuba diving tanks. Then neon, you got advertisement light bulbs. Okay, light bulbs, and then you got argon used in you got 2 types. Okay, one used in electric bulbs, the second one to provide inner atmosphere, okay, for welding. So then krypton you got 2. One is the retina one is the flashlight of camera, also krypton. Okay, then the xenon also got 2. Okay, xenon is used in anesthetics. This one is xenon. Okay, anesthetics and lighthouse lamps for xenon. So the only one correct here is donkey. Yeah, radon used to treat cancer is correct. Okay. Question 6, you got Form 4 Chapter Chapter 4 also. Table 1 shows the states of matter of two elements in group 17 at room temperature. Okay, so we talk about group 17. Okay, so you have to remember one thing lah. Yeah, so group 17, which is we have the first one is fluorine, chlorine, bromine, iodine, astatine. Okay, which I don't answer. Question 4. Okay, so I talk about question 6 first. Okay, so and then which of the following statements is correct about the elements? Okay, so in this case, X. Okay, gas got two. Okay, fluorine and chlorine in room temperature is gas. Bromine is liquid. Iodine solid. Okay, so in this case, A, Y can conduct electric current in molten state. X cannot conduct electric current in all state. Doesn't matter which one. All cannot conduct. All cannot conduct electricity. Okay, because they are covalent compound. They are covalent compound. They between fluorine atom or between chlorine atom, they will share electron to each other. Okay, so A is wrong lah. Okay, all cannot conduct. X and Y cannot conduct. Okay, so and then we have B. Y dissolve in water while X does not dissolve in water. Y dissolve in water. X does not dissolve in water. Okay, actually all can dissolve in water. All can dissolve in water. Okay, and actually lah, by that like, actually iodine is harder in dissolving water. Yeah, because the reaction is very slow. Okay, so but actually all can react with water to form the like example Cl2 react with H2O. You know this reaction, Cl2 react with H2O to form HCl and HOCl. Okay, I2 also can, but I2 normally, if anything, I2 is the one that struggling to react, to dissolve. Okay, not chlorine. So B is suitable. C, atomic size of Y is smaller. Down the group, fluorine is smallest, iodine bigger. Okay, so if C atomic size of Y is smaller, wrong. Okay, iodine is very big, wrong. Okay, so you assume X is chlorine, Y is iodine. Okay, and then color of X is darker. Okay, correct. Okay, so I don't know if you remember, fluorine is green. Fluorine is pale yellow gas. Chlorine is greenish yellow gas. Okay, turning from the brightest to the darkest. Yeah, brightest to darkest. So it means Y should be darker, correct. Yeah. Bromine is reddish brown. Then you got iodine is purplish black. About question 4, you just write the equation only. Then you balance the equation. That's it. You write the equation that you balance. Okay. Potassium iodide is Ki. Lead-2 nitrate is PbNO32. Yellow precipitate is when Pb2 plus attract I minus. The color solution is K plus attract NO3 minus. Then you balance because the I got 2 at the right. So Ki times 2. Then you got 2K at the left, sorry. KNO3 times 2. Then you just find, after balancing, you just find which one got 2, which one is 1. Just read through everything. Then you can get the answer. Yeah, the correct answer is C. Okay. And then we have question 7. This is Form 4, Chapter 4. Okay, diagram 3 shows the chemical formula of oxides of elements of period 3 in the periodic table of elements. This one is period 3. Okay, so obviously you know lah. Okay, number 11 is sodium oxide, magnesium oxide, aluminum oxide. After aluminum is the silicon dioxide, or call it silicon 4 oxide. Okay, then you got phosphorus pentoxide, sulfur dioxide, dichlorine heptoxide. So they ask what is the use of element X? Means element X silicon. Okay, what is the use of silicon? Okay, so the best answer is silicon. Oh, here they ask the use of silicon. Okay, I'm sure even if you don't remember, don't know, physics you learn this. Yeah. So physics learn this. Okay. So the answer is B. Yeah, the answer is B. Used as a semiconductor substance. Like example, your computer microchips is one example. Okay. So no need to write anything. Okay. In physics, you learn about this. How does the silicon work? Form. Okay. So yeah. And then we have question 8. Which of the following illustrations, but you have to know, after between the aluminum and phosphorus is silicon. Okay. So I think paper 1 they won't give the periodic table. And then question 8. This one is form 4 chapter 5. Okay. Which of the following illustrations shows the information of hydrogen bond? Hydrogen bond. Okay, I don't know if you still remember what is hydrogen bond. Okay, so between the molecules. Yeah, so this one very easy one. Okay, the rule is, of course, the molecule inside must have hydrogen. Okay, but depends. Okay, so inside the molecule, whether you got HO bond or HF bond or NHN bond. Yeah, either one. Okay. Then it's not inside. Inside the bond is called covalent bond. Okay, I told you right. So it's between the molecules. Okay. The hydrogen from the first molecule will form hydrogen bond with the oxygen from second molecule. Okay, this is called hydrogen bond. HB, HB not doesn't stand for happy birthday here. Stand for hydrogen bond. Okay, so it means HF, HO, HN, H5. Okay, not my birthday. Thank you very much. So in this case, the answer is B. Correct. Yeah, you see the water molecule. The O from the first molecule form hydrogen bond with the H from the second molecule. You might ask, second one, A. Chlorine cannot form hydrogen bond. Okay. HCl not. HF can. If we here is HF is correct. Then C and D not to tell because only if the molecule inside HO, HF, HN only. Okay, not CH, not CO. Okay, not, we don't care. Actually, it's donkey, almost correct, but it should point like this, not like this. Okay. Question 9. Which of the following particles are formed from a dative bond? Okay, this one is form 4, chapter 5 also. Dative bond. Which of the particles are formed from a dative bond? Okay. So in this case, this one is very easy question actually. Okay. So if you don't know what is dative bond, okay, it's some sort of covalent bond where the hydrogen ion is poor guy. Okay, then you have somebody to share 2 electrons, a lone pair of electron to the hydrogen ion, which is water, and the other one is which is with ammonia molecule. So with water, we form hydroxonium ion. With ammonia, you will form ammonium ion. So the answer is very easy. Okay. H3O plus and NO4 plus. A. So it's very easy. Okay. This is number 2 lah. Okay. Hydrogen ion means the oxygen has a lone pair of electron, then can share to the hydrogen ion. Okay. Ammonia, the N from ammonia, the nitrogen from ammonia, also has a lone pair of electron, the extra electron, 2 electron, which is called a lone pair of electron, share to the hydrogen ion. Both can form the compound here. Okay. Okay. Question 10, Form 4, Chapter 6. Okay. Diagram 4 shows the reaction that occurs on salt J. So salt J after being heating of salt. Okay. Now this one always they frequently come out. Okay. Yellow solid when hot, white when cold. What is this? So yeah, okay, this one is ZNO, correct? The other one quite similar one. The other one is called the brown when hot, yellow when cold. That one is PbO, lead 2 oxide. This one is ZNO. Yeah, correct. This one I hope you already get into your head. Okay. So it means the other one is the other gas is colorless gas turns moist blue litmus paper to red. And does not rekindle the glowing wooden splinter. Oh, this one is a bit funny, okay? A bit interesting. Does not rekindle glowing wooden splinter. It means it is not oxygen. And this one is a bit challenging, a bit funny, okay? So it's not oxygen. Okay. So, but it can turn the blue litmus paper to red. Okay, so this is actually you might think this is nitrogen dioxide, right? But it cannot be nitrogen dioxide because it's colorless. Nitrogen dioxide is brown gas. Okay, so the colorless one, it's funny enough. Okay, this part is not carbon dioxide gas. Okay, this one is a bit funny. Which the following is correct. Okay, this is sulfur trioxide gas. Yeah, you know your sulfur dioxide and sulfur trioxide, both are acidic gas, but it's a colorless gas. Carbon dioxide normally they don't tell you this. Carbon dioxide normally you test with lime water turn cloudy. Yeah. So in this case, it's not carbon dioxide. And this objective is quite challenging. Okay, so it means salt J. If you see sulfur trioxide, salt J is zinc sulfate. Yeah. Okay, they are most of the sulfate salt. Okay, when you heat, no reaction. But if you heat zinc sulfate, iron 2 sulfate, copper 2 sulfate, it can turn to the oxide and the sulfur trioxide, which is a colorless acidic gas. Okay, so the answer is A. A is only possible. Okay. This right. It is a bit funny. Okay. You might ask, only got heating only got carbonate and nitrogen. You know, objective question is like this. Okay, so they will come up the thing that you list as better. Okay. Just choose got zinc one if you don't know. True. So no need to even think about the guess set. If this is the option, like the option is so easy. Okay. Question 11 from 4 chapter 6 also. Okay. Diagram 5 shows an apparatus setup for an experiment that has been carried out by Ahmad. Ahmad pour the lead-2 nitrate solution into the sodium chloride solution. What do we get? What happened after you add together? PbCl2, what happened? Okay, I write the equation. Okay, if lead-2 nitrate react with sodium chloride, Pb2 plus attract Cl minus to form PbCl2, Na plus attract NO3 minus to form NaNO3. And just to balance times 2 NaCl times 2 NaNO3. So what happened is, the PbCl2 is, what happened? Is this salt soluble or insoluble? You must already think. Okay. So it's insoluble. You will get white precipitate at the bottom. White precipitate. Formation of precipitate form. Okay, which is a PbCl2. And this is NaNO3. Okay, so the answer is very simple. The answer is so simple. The answer is B. Not even see, don't even need to see other things. There's no color, nothing. Okay, so all these are colorless solution, white precipitate, colorless solution. Yeah. Yeah, it's a bit like Form 4 chapter 7 actually. But yeah, actually you kind of true. Okay, so you have question 12. This is Form 4 chapter 8. Okay, the following information is about the uses of substance L. Cutting this, break this tungsten carbide ring. This is the advanced ceramic. Okay, if you see cutting this, break this advanced ceramic. Advanced ceramic normally mixed with the clay and some chemicals like silicon carbide or this normally made by silicon carbide. These two made by silicon carbide. These are made by tungsten carbide. The ring made by tungsten carbide. Okay. So which of the following characteristics make L suitable to be used? Low compression strength. No. Okay. Low compression strength is, I forgot it. I think it's steel. Okay, steel bar has low compression strength. Nothing to do with advanced ceramic. Low electrical conductivity. Nope, wrong. Okay, so of course, all this electricity, all this ceramic, okay, it cannot conduct electricity at all. Okay, actually, it can conduct electricity. Yeah. If you add some chemical, okay, if this traditional ceramic cannot conduct, okay, if it is like like the uh brick piece, all this can conduct. Okay. And then we have higher abrasion, yes. Chemically inert, yes. Higher abrasion means don't easily get scratched. Okay. So like your brake disc on your motorcycle, on your car. Okay. So that's why it's not like you every day or you every week, every month, you have to change the brake disc from your on your car. Okay, or on your motor. So this one tahan all the friction. Chemical inert means won't react with other chemicals. Okay, so the answer is Donkey. Question 13. This is Form 5, Chapter 1. Which of the following pairs of reactants is correctly matched to its reaction? Okay, so this one, I would say the simplest example is just to calculate the oxidation number. Easiest one. Okay, the easiest one here you can find is the CuO first. Maybe you ask me, NO3 is a bit difficult, right? But you know, CuO is simplest. So you know, normally Cu is 2 plus, right? So normally Cu is positive 2. Cu is positive 2. Copper atom alone is 0. So if you see this one, is the decrease in oxidation number. Decrease in oxidation number. This is reduction. Okay, this is reduction. So you just look for, oh, you know, CO undergo reduction. Very easy, ma. Okay, fine, which one undergo reduction? Yes. Undergo reduction itself is an oxidizing agent. So of course B should be wrong. C is correct. D is wrong. Okay, so it can be A and C lah. Then the other one, it means the other one, ammonia, is reduction. I mean oxidation. Because you can see that this one, nitrogen atom, nitrogen molecule is 0. You know, hydrogen is always positive, right? Hydrogen is always positive, right? Okay, so hydrogen is always positive, positive 1. But here you've got three hydrogen. So it means N should be negative 3. Because 3H means 3 times positive 1 become positive 3. If the H is positive 3, then the N is negative 3. Okay, we don't care about balancing number, we don't care. So it means negative 3 to 0 is increase in the oxidation number. So you know this is oxidation. Oxidation means itself is a reducing agent. Yes. Okay. So undergo oxidation itself is a reducing agent. Oxidation for energy, reducing agent. So the best answer is A. Okay. Question 14 from 5 chapter 1. This one is the electrolysis study. Okay. Where, you know, this assessment is trying to electroplate the ion key. Okay. To make the ion key coat with metal X, surrounded with metal X. So this problem is, okay, after 10 minutes, it is found that there are no changes. No changes means nothing happened. The ion key cannot be coated by metal X. Why? It means the oxidation and reduction doesn't happen. Means, what's the problem? Okay, then they tell you all the Enoch values. Okay, for iron is negative 0.44, hydrogen is 0.00, then you got X is positive 0.34, the OH minus is positive 0.40. Okay, so this case, Mr. Cole, the day we discussed something, you know, right? He also didn't think, right? So in this case, okay, we have to draw the battery. I forgot to draw the battery in exam. If it is electrolytic cell, and then you get 0 mark. I'm not 0 mark, but I think lose mark. Must have battery for electrolytic cell. Must have battery. No battery wrong. Okay. So in this case, no, forget all. Okay. So what happens? You see the battery, if it is short, is negative, long is positive. Yeah, interpreting, yes, should have battery. Okay, and in a correct direction. Okay, iron ring, same, right? Doesn't matter, iron ring, iron spoon, iron key, whatever, iron nail, same thing only. So in this case, okay, You know electrolysis means electrolytic cell. Electrolytic cell is A plus C minus. A plus C minus means anode positive, cathode negative. Anode positive, cathode negative. You have to know one thing. In electroplating, okay, this metal is the sacrificer. Okay, sacrificial metal. Okay, it will sacrifice itself to protect the iron key. Normally, sacrificial happen at anode. So it means your metal should connect to anode. Your the one that need protection supposed to be at cathode. Okay, so but in this case, you see properly, this doesn't match. Yeah, so it means the correct way of happening is the batteries should be like this, not like this. Yeah, so the terbalik. You can change the direction of the battery, or you change the key and you change the setup between the key and the metal X. Okay, then only metal X will sacrifice, become X2 plus. Okay, okay, because let's say you got X nitrate. Okay, X nitrate. So what about this? Let's say you got X nitrate. X nitrate got X2 plus ion and O3 minus. Okay. The reason I write X2 plus because I know positive 0.34 is copper. Okay. So this I can completely say it's copper. And written here is X2 plus. Okay. So in this case, then you got your solution contain water H plus OH minus. So then between okay, then these two ion go to cathode. These two ions go to anode. Okay. So and then it's supposed to be anode. Okay. And then in this case, X2 plus and H plus. Which one inert value more positive? X2 plus. So X2 plus become X by undergoes reduction receiving electron. So the X2 plus become X. That's why the iron key will be coded by X metal, which is copper metal. Then between these two ions, we don't choose because metal will contain the active electrode. Metal X, which is copper. This one metal X become X2 plus. By undergoes oxidation, release electron. So, but all this doesn't happen if my battery terbalik. Or you can say if these two things terbalik. So the best thing is, the problem is C. The solution is C. Okay, change iron key to cathode, metal X to anode. This one is question 15. Form 5, chapter 1 also, redox. Okay, so the teacher said today we will be carrying out the two experiments to study the electrolysis process of two solutions M that have different concentrations. Solution M, the two solution M that have different concentration is keyword. Okay, so yeah, so you can see, one is with iron spoon, one is with iron key. Okay, solution X and Y. So, which of the following is correct match of the type of solution used and the observation at cathode in each set? Okay, so it means they ask what is solution X, what is solution Y? Eh, wrong idea. Oh, sorry. Yeah, my brain not working. 15, 15. Damn. Yeah. I should look at question 16. Yeah. That's why I don't like this kind of setup. So confusing for me. Yeah, question 50 is like this, okay? What is solution M? If different products are found at the anode when the experiment carried out. Okay, so you got two solution M. Basically very simple. Yeah. So two solution M, different concentration. It means both beaker have the same solution, but you have different concentration. And let's say one is 0.5 mole per meter cube, and let's say one is 1.0, the other one is like 0.1. Okay, say 0.01. So the difference is, okay, the same thing, but it will affect the product. So A is H2SO4, B is HCl, C is H2CO3, D is HNO3. So very simple one. Okay. So we take the ion and C lah. We split the ion and C. I like my cancer paper big question. Yes. Okay. Because the publisher want to save paper, right? So and then you have H plus NO3 minus. And then you know if you analyze the electrolytic cell, normally you know that you got one more ion for the negative ion. So all this we call to we will go to cathode undergo reduction, H plus undergo reduction, or we get hydrogen gas. So no problem. Okay, cathode will produce cathode what is H plus will turn to H2. All the colorless gas coming out. But the anode, it depends. Okay. Okay. If this doesn't matter if it's A, if it is A, C, D, all these sulfate, carbonate, nitrogen. Normally, we don't choose this ion. Normally, the one that we choose to undergo oxidation at anode is hydroxide ion. Because the hydroxide ion has the more positive E0 value. And sorry, more negative E0 value. Sorry. More negative E0 value. But except B. Okay, if we adjust the concentration, then for Cl minus, will determine the difference. If it is like high concentration, okay, the answer is B lah. If it is high concentration, like for HCl, then the Cl minus undergo oxidation becomes Cl2, become a greenish yellow gas produced. If the concentration is very low, then you don't choose Cl minus. We choose OH minus hydroxide ion undergoes oxidation, become oxygen gas. Yes, dilute cannot undergo, the ion cannot undergo oxidation. Only the OH minus can. Okay, then you will get your colorless oxygen gas. So it means that's why they're talking about different product if you adjust the concentration. If it is high concentration for HCl, then you get Cl2. If it is low concentration, then you get oxygen gas. But if you adjust others, won't change anything. Because the concentration only apply to the halide ions, the Cl minus, Br minus, I minus from group 17. Yeah. So the answer is B. Okay. 16. Table 2 shows two sets of apparatus setup of an experiment to electroplate two types of substances. Okay. So this one is also Form 5 Chapter 1. Oh no, this paper, a lot of questions for Form 1 Chapter 1. Okay. So in this case, which of the following is the correct mesh of the type of solution used and the oxidation at cathode in each set? Okay, so they ask what is solution X, solution Y. And what happened to P, what happened to Q? At cathode. Okay, observation at cathode. So we analyze one, okay, for the cell. So you know if you got battery one, both are electrolytic cell. No need to see it here. Okay. So but if you know this is electrolytic cell and you see the battery positive, negative, positive, negative, long positive, short negative. And you know electrolytic cell, the rule is A plus C minus. So anode positive, cathode negative. Which is correct. In this case, which is correct. Okay. Because the sacrificial metal supposed to be an anode, the iron, whatever iron spoon, iron key, iron ring, supposed to be at cathode. Okay. So and then in this case, one using copper plate, one using silver plate. So this one very easy one. Okay. So if normally if you got copper, then your solution should be supposed to be copper to ion. Okay. Supposed to be copper to ion. Supposed to contain copper to ion solution. But of course, okay, it can be either copper to sulfate, copper to chloride, copper to nitrate, doesn't matter. As long as contain copper to ion, contain soluble copper to salt solution. Okay. And then what happens? You know it lah. Okay. Normally, if you see this kind of electroplating, you know the anode undergoes oxidation, release electron. Cathode undergoes reduction, receiving electron. Copper atom release electron becomes Cu2 plus. At the ion spoon, copper to ion become copper. Copper, you know what's color, right? What about the cathode? This is cathode, right? So you know this is brown solid deposited. So very simple. Yeah. If it is silver, then you know all your solution is supposed to be silver nitrate. Not iron. We don't care about, we don't tell me X and Y use iron to nitrate, no such thing. Okay. You see, they saw the option they give you, sometimes they give you whatever iron to nitrate. They don't care. This one, no such thing. Okay. Either it should be copper nitrate or silver nitrate. Okay. So then same thing, right? I will repeat. Same thing means silver atom release electron becomes silver ion. Silver ion receive electron becomes silver at the key. So the silver, what is the observation at cathode? What is the color of silver? Gray solid deposited, correct. So we can just watch lah, okay? Just observe. A X is silver nitrate. Wrong already lah, okay? No need to see also wrong already lah. All this the balik. Okay. Then B, copper to sulfate, correct. Silver nitrate, correct. Brown solid deposited, gray solid deposited, correct lah. B is correct already. Then C, correct. Terbalik for the PQ. Donkey, wrong, correct. So the answer is B. Okay. Okay, question 17. Diagram 8 shows the structural formula of compound X. This is form 5 chapter 2. Okay, this is, okay, what is the compound this? What is the homologous series? If you see this, what's the group? If you see this, who tell you hydroxyl? Who tell you one? Okay, so wrong. Okay, so it's not hydroxyl. This is carboxyl group. COOH. Mister, look properly. You got C double O. Okay, COOH. What is the homologous series called? Carboxylic acid. How many carbon? 4. So what is the name? What is the name? 4 carbon is called what? Ooh. And for those who still lost, myth is 1, if is 2, prop is 3, build is 4. So the name is called butanoic acid. Do you know what's formula? I mean, already drawn for you, so you know that. The general formula is CnH2n plus 1 COOH. You know when you got 4 carbon, N equals to 3. So that's why you got C3H7COOH. Very good. So the thing is they ask, what is the product form when the X react with alcohol that has 3 carbon atoms per molecule? Okay, so you know that alcohol is the CnH2n plus 1 OH. Okay, so 3 carbon means you will get the alcohol C3H7OH, which is a propanol. That means in this case, butanoic acid react with propanol. Okay, so what do we get? So I write for you lah. C3H7COOH plus C3H7OH. Then what do you get? You will get, you remove water. So you combine C3, H7, CO, O, C3H7, and H2O. But they want the name, right? So basically, butanoic acid and propanol. Butanoic acid and propanol. So propanol become what name? For ester. Yeah, this is ester. Okay, basically. In the middle got CO. Propanol become propyl. Remember, for ester name? Butanoic become butanoate. So the answer is C. So that's why knowing the name also very important. So I asked, why is the carbon? Why is 4 carbon called? Then you suddenly forget for me, then trouble. So basic. Myth is 1, build is 4, prop is 3. Basic. A pen is 5, hex is 6. This is another form 5 2. Diagram 9 shows the structural formula of a hydrocarbon Q. What is the name of Q? Okay, so obviously, the moment your eyes already focus on the triple bond, okay, you know this is alkyne. You know this is alkyne, okay? But the thing is, in this case, uh, you have to find the longest carbon chain. Okay, you know this a bit look confusing. Do you know where's the longest carbon chain? You know this is the isomer, right? So the way they draw. So do you know what's the best chain? Don't tell me only like this. 1, 2, 3. 1, 2, 3 is not the longest chain. The longest chain available is 1, 2, 3, 4. Or you can say 1, 2, 3, 4, doesn't matter. Same thing lah. Okay, up or down, same thing. Then you can say the bottom have the branch. Yes. Okay. Of course, you should prioritize the triple bond first. Okay. That's why if it is 1, 2, 3, 4, or you can say the ballet 1, 2, 3, 4. Of course, what number do you choose? You always focus on the triple bond or double bond first. So triple bond is 1, 2, 3, 4. Of course, you choose 1. So it means you don't follow the order of this. So we choose 1. So you know this is the branch. The branch is at the 3rd carbon. The branch contain 1 carbon is called What 17B? 17C. C. They ask about the ester, the product, not the acid. I know this is butyric acid, but I didn't ask for this. I asked for the product formed when react with alcohol. Okay. So in this case, yeah. So what is the name called? The branch is at the carbon. It's called 3-methyl. Remember, the branch is called methyl. If there's one carbon only, 3-methyl. What is this called? 4 carbon is called what? But. Correct. But. The triple bond is at first carbon. Build one ion. Yeah, triple bond is called alkyne. Okay, Y and E. So 3-methyl build one ion. The answer is B. Okay. Why we prioritize the position of triple bond or double bond first? Yeah. The following equation represents a process to produce C2H4 and J. This one is also form 5.2. Okay. Now this is a very rare question. Okay, where 99% of students will not remember this part. Okay. So this part where they add aluminium oxide and silicon dioxide. Actually, this is 2.1. If you still remember about the fractional distillation and the cracking process. Yeah, so where you obtain your all this petroleum gas, kerosene, all this diesel gas. I don't know, diesel oil, sorry, diesel oil, bitumen, all this. If you see about this process, okay. So where I told you, through the first process of fractional distillation, where because your petroleum, petrol, kerosene, naphtha don't have enough supply with a very high demand. That's why you have to do process number 2, cracking. Okay, so cracking is to achieve the demand of the shorter chain hydrocarbons. Okay, because petroleum needs very high demand. Okay, so where the catalyst is the mixture of aluminum oxide and silicon dioxide with the 600 degrees Celsius. Okay, where you crack, crack means you crack the long chain carbon into the shorter chain. Okay, you cut the longer chain into smaller molecules. Like you cut C7H16 into C2H4. Okay, if you cut 2 parts, total is 7. Then C7, if you cut 2 parts, then it becomes C2 and C5. So very easy. Okay. Then you have 16, you cut into 4 and 12. So you get C5H12. Very easy. C5H12. C5H12 is an alkane. Okay. Alkane. Single bond. All single bond. Okay. So all single bond C. With 5 carbon. Donkey got 6 carbon. Too much. Can just use math to solve. Exactly, this part is so easy. Okay, but some people don't know what happened because they don't know what is meant by cracking. Yeah, they just look at this. What is this? Okay, never see before. So yeah, and also sometimes they don't know C5H12 is alkane. Okay, they go and choose that one, triple one. Okay, then you have question D, also form 5.2. Okay, which of the following test is correct for the molecular formula and type of bond of alkyne? Simple. Alkyne is, I told you just now, is carbon triple bond. Okay, so the only part correct is C and D there. Okay, D is not correct. Okay, read the formula is not correct. Okay, the formula correct is B and C. A is matching with our bond, correct? B, this one is triple bond. The formula is triple bond. Okay. C is not correct. D, the formula is from the double bond, the alkene. So wrong. Okay. Any question? Okay. So question one is also from 5 chapter 2. Which of the following conditions are used in the hydration process of ethene? Okay, so ethene is C2H4, which is contain double bond, as you know, which is alkene. So hydration means what? Hydrated means adding what? Ethene add water. Okay, C2H4 add water become your alcohol C2H5OH. This one is your ethanol. Okay, where the condition is just remember 300 degrees Celsius, 60 atmospheric pressure. The catalyst is phosphoric acid, H3PO4. So the answer is B. Very easy. Yeah. Any question? A is esterification, where the catalyst is concentrated sulfuric acid. Yeah. Then C is hydrogenation. Yeah. Donkey is Haber process. This one is to produce ammonia, where you use iron as a catalyst. Okay. Hydrogenation is alkene, add hydrogen become alkane. Yeah. Question 32 is from 5 chapter 3. Okay, diagram 10 shows the energy level diagram of a chemical equation. So they tell you x2 plus y2 become 2xy close and n, and the delta H they give you positive Z kilojoule per mole. Okay, so you notice the endo, very easy. Okay, positive sign means indicates it's endothermic reaction where the temperature of the mixture decreases. Okay, decreases. It means the heat is absorbed from the surrounding. Okay, this one is one package. Okay, so and the total energy of reactant is lower than product. Yeah. So they ask reaction between X2 and Y2 is an exo wrong, is endo. When 1 mole of 20 is C, yeah. So and then when 1 mole of X2 and 1 mole of Y2 react to form 2 mole of XY, Z kilojoule of heat energy is released from this is absorbed, not released. Total energy content for X2 and Y2 is higher. Okay, X2 and Y2 is higher, wrong. Okay, X2 and Y2 is lower than XY. So wrong. Is lower. So the answer is not B. Okay, temperature of mixture decreases. Correct. Okay. Question 23. Diagram 11 shows the apparatus setup of 2 experiments had been carried out by Ali. So this is also from 5 chapter 3. Okay, you've got 2 set experiment. Set 1, metal M add into X SO4 solution, you will get brown solid deposited. Okay, this one is the heat of, these two are the heat of displacement. Heat of displacement. Okay, So where of course these two both reaction means metal M can displace metal X, metal N can displace metal X. Both you got brown solid deposited. Okay, so it's very obvious. Okay, brown solid is copper. I'm sure you know already at this point. So it means X4 is copper 2 sulfate. This one you know lah, simple. Then the copper 2 ion will be displaced, become copper metal, copper solid. So you might ask, which of the following statement is correct about both experiment? Okay, so in this case, where you be careful one thing. Okay, you look at the thermometer. Yeah, the thermometer is a bit detailed. Okay, look at which one have big changes, bigger changes. Temperature increase a bit higher, a bit more. Metal M or metal N? You see this is the reading, the starting, then the ending. So obviously, okay. So of course, the changes. This one is higher. This one is lower. Metal M lower, metal N higher. Okay. So higher means normally the metal is more. Normally the metal is more electropositive. Normally it's a magnesium or on top. Okay. So you can say, of course, metal N is more electropositive than metal M. Okay. N is, okay, this one is wrong lah. This one is less. M is less electropositive. N is the most electropositive. Okay. Which is correct, of course. Okay. Of course, correct. Okay. The order is metal N, then copper. Yeah, so B is correct. X is more electropositive. No, less is less electropositive because S can be displaced. X is more, okay, wrong lah. Again, less. Okay. So less. So that is B. Okay. And then we have, now move. Question 24. This is also from 5 chapter 3. This is the heat of talking about the heat of neutralization. Heat of neutralization. Okay. So you see the reaction between acid X. Okay. Don't know why. Don't understand what you mean. Okay. So reaction between acid X and sodium hydroxide solution, which is an alkali, of course. Okay. NaOH released 114 kilojoule of heat. Okay. While the reaction, it means X plus NaOH, you will get 114 kilojoule of heat. The Q is 114. If it is acid Z, react with NaOH, then you only get 57 kilojoule. Okay, so which of the following pair are correct about the acids? Very easy lah. Okay, why is it got twice? Why is it got twice the amount? Okay, it means very easy one. If you think about this, only one thing is possible. Acid Z is a monoprotic acid. Monoprotic acid like HNO3, HCl, or like CH3COOH. But I don't think it's even CH3COH. Okay, in this case. It's not even CH3COH. Yeah, because normally 57 kilojoule means already strong. Both are strong acid. Okay, so where metal X twice, right? Twice means diprotic acid, right? Sulfuric acid, where you produce 2 mole of hydrogen ion. That's why the concentration is double. That is why the heat released also double. where monoprotic acid only produce 1 mole of hydrogen ion at a time. So of course, X, you have to find the sulfuric acid. Where sulfuric acid? Okay, C. Okay, then Y is a hydrochloric acid. Basicity of Z should be monoprotic. Correct, tidak? Okay. Basic. Actually, they write white. What do you mean? Huh? Oh, yeah, yeah, yeah. Supposed to be that. You have sharp eyes, sharp eyes. Yeah. So, and then you got question 25. This one is Form 5, Chapter 4. Diagram 12 shows the apparatus setup to determine the elasticity for two types of substances. Okay, so this one is very easy. So it's where you see both rubber P and rubber Q. Okay, uh, hang a weight of 50 grams. Okay, so it was found that Q elongated while P did not. Okay, elongated means the length has been extended, become longer already after the weight is removed. Okay, you know, if those rubber that elongated means they are the weaker rubber. Okay, normally it's natural rubber. Normally supposed to be natural rubber. Okay, then the other one is it means P is if Q is natural, then P is either it is vulcanized rubber or you can say it is synthetic rubber. Both are quite short, same thing. Right? Okay, so what is Q? Very easy. Okay, so polyisoprene, correct. Answer is A. Sorry, it's not polyisoprene. Wait, let me find a bit. Wait, the answer a bit funny. Okay, so of course it's not C, it's not D. C is synthetic. I mean, same to Y lah, same to donkey lah. Donkey is synthetic. Okay, numerous silicon rubber used in the automotive components, used in the windscreen wiper, used for the medical implants, medical cables. Okay, all these baby care product, whatever lah. Okay, a lot of things. That's cute. There's silicon rubber. Natural rubber used in medical grade gloves, which is also a synthetic rubber. Polychloroprene. I think the answer is a bit wrong. Less elastic. Polyisoprene. Polychloroprene is neoprene. Okay, neoprene, which is also synthetic. That's the scheme a bit off. Okay, so the supposed to be A lah. Polyisoprene is natural rubber. You give me give me a few seconds to check this. Yeah, so I think I understand why it's not A. Yeah. So okay, if it is polyisoprene, okay, the thing is they ask elongated means they are talking about the rubber that is least elastic. Okay, so among all these least elastic, okay, actually the answer should be B. Okay, so it's a bit funny. Okay, but apparently, polyisoprene is even more flexible, more elastic. If you still remember how you draw it, the polyisoprene structure, it looks something like this. If you still remember, okay, something like this. Yeah. So this is the polyisoprene. Okay. So but apparently, uh, this one is even more flexible, more elastic. Okay, like your rubber band. But If let's say the one is less elastic, if you change this thing, okay, okay, you see, around the same thing. Oh, my screen can move. Uh, okay. So let's say if I got the same thing, then this one instead of CH3, this one become chlorine. When you attach to chlorine, this one is called polychloropene. So apparently polychloropene, uh, what happens is when you attach to chlorine, chlorine makes the rubber less rigid. Okay, makes the rubber more less rigid. Sorry, more rigid. Sorry, more rigid means not flexible enough. Not flexible enough to move freely. So apparently, when you add chlorine, this will happen into the structure. Okay, chlorine makes it less movements in the rubber. That's why it's hard to pull the rubber. Okay, make it more elastic. Yeah. So even though it makes it more elastic, doesn't mean it's a bad rubber. Okay, just that in this case is less elastic. That's it. So it's B. Okay. Well, this is a question. I think 90% of people get wrong. I would say. So yeah, sometimes SPM they come out with weird question. Okay. It's a bit deep question. Okay. So question 26. Diagram 13 shows a conversation between Chef Karim and Chef Osman. So apparently polychloride is a least elastic rubber. Okay. So diagram 13 shows a conversation between Karim and Osman. So this one is Form 5, Chapter 5, I think you just learned. Okay. So this chef Karim say this food is lack of taste. No taste. Okay. So maybe I forgot to put an ingredient just now. So which of the following is the ingredient meant by Chef Osman? Lack of taste means what? What they want to add? Lack of taste they want to add? Flavoring. Not enough flavor, not enough taste. So which one is the flavoring? Wrong, Mr. Kong, wrong. Okay. So the answer is aspartame is correct answer. A. Yeah. Which one? What are the example of flavoring agents? Aspartame is one. When you add the Coca-Cola, remember the soft drinks? I told you, okay, aspartame is the replacement of the normal sugar. Okay. Uh, Aspartame, stevia. If you buy some Coca-Cola at the back, you can see the labeling. Not even Coca-Cola, like normal, like us coffee latte, whatever. Okay, you buy and see. You see the labeling at the back. You can see there's written stevia or sometimes aspartame. Another example is MS3 lah, monosodium glutamate. We share the give, of course. Okay, so it can be this. Ester also can. It also can be ingredient. Yeah. So B is pectin is emulsifier. Okay, lecithin is stabilizer. Okay, same, around same lah. Pectin, lecithin, all same. Around same. Benzoic acid is preservative. But who cares about preservative? Okay. So I want the food taste better, not store longer in this case. Okay. Eat acid. What do you mean eat acid? So in this case, okay. Let's look at question 27. Another form 5, chapter 5. Okay, another food additive. Okay, so diagram 14 shows the situation observed by Suraya when slice of a fruit was left on a table overnight. Okay, so he cut cucumber. Okay, he cut off. At the beginning is light green color. After you put overnight, the cucumber become brown color, just like an apple. Okay, just like an apple. Same thing happened. Okay, so if Suraya suggests to produce a cosmetic product using the fruit, Okay, what is another basic ingredient, okay, that should be added by Suraya to overcome the problem? Okay, this one is not food additive, sorry. This one is the, apparently it's the cosmetic. Okay, but actually it's not the same. Doesn't matter it's the food additive or the cosmetic. You have the similar thing, yes, to prevent the thing turning brown. Uh, okay, not the same, but a bit different. Okay, this one is not the expiry date, no. This one is the antioxidant. Okay, in food additive, it's called the antioxidant. Okay, so in this case, the reason also turning brown because actually it's also being oxidized already. Okay, it's not preservative, no. No. Okay, so not preservative. So in this case, you see, if you expose to air too long, not only turn brown, but already dry. Okay, not what, not don't have enough water already. So in this case, if you want to retain the water, the moisture, the answer is donkey. Supposed to be moisturizers, yes. Oh, I think the girls should be strong in this question. Correct. You got correct. The answer is donkey. Moisturizer. Okay, so moisturizer means they want to retain the moisture of the cosmetic product. Means you dry. It means if you expose to air too long already, then your cucumber is dried. In order to retain the watery, you have to put moisturizer to make it more moisture. Same thing the cosmetic. Okay. So they should, yep. It's a bit tough actually. Not that easy for some students. Okay, so question 28. Form 5, chapter 5. Okay, I know this one I haven't teach in normal class yet. Okay, I teach in August week 1. So diagram 15 shows a type of product from an industry, from a factory. This one is the nanotechnology one. Where they give you one cloth, okay? So which of the following statements best explains how the application of nanotechnology can enhance the quality of the product? Okay, this one, okay. So enhance, okay. Very easy one, okay. Your shirt, if you see inside of shirt, only got one thing, okay. I want to have the anti-wrinkle shirt. And you know, as wrinkle means like easy get messed up. No mess up, I mean messy. Okay? So, like you have to iron many times. If it is anti-wrinkle, right, the shirt, you iron 1 or 2 minutes, already enough. Yes, okay, correct. Okay? So, and then you want to have the shirt that is anti-wrinkle so that you don't have to iron many times. You iron 1 or 2 minutes, then your shirt already can be straightened. Okay, so the answer is A. Very easy. If you see this kind of clothing, you just see the anti-wrinkle enough already. Clothing, you see anti-wrinkle. Yeah. Because this anti-wrinkle is actually related to this nanotechnology. Okay, one of them. Question 29. This is also from 5, chapter 5. Okay, also 5.5 nanotechnology. The following information is about substance Q, where substance Q has a very low electrical resistance. Okay, means it can conduct electricity easily. Okay, in another way you say, burns at a lower temperature, the most reactive carbon electrode. Okay, so what is Q? Okay, so this one is not graphite. This one is graphene. The answer is B. Yeah. You know your handphone battery also contain graphene. Yeah, this kind of laptop battery, handphone battery contain graphene. Okay, it's one of the example. Yeah, graphene. And normally 5.5 nanotechnology, they talk about more about graphene. Okay, actually graphene is form 5 to the 5, yes. And in this case, question 30. Okay lah. Okay, from question 30 almost got calculation there. Okay. So what is number of magnesium ions that can be found in 8.88 gram of magnesium nitrate? Oh, this one is form 4, chapter 3 calculation. Okay. So very easy lah. Number of magnesium ion. Oh, this one you have to do the number of mole question lah. Okay, obviously. This one you have to apply two formula for number of mole. Number of mole equals to mass over molar mass. Number of mole equals to number of particle over Avogadro constant. So in this case, before that apply. How many magnesium ion in magnesium nitrate? In order to form magnesium nitrate, how many magnesium ion? One, right? 1 Mg2 plus ion. How many nitrate ion? How many? 2. Yeah. Okay. If they ask for nitrate ion, it's 2. If they ask for magnesium ion, they only 1. This one no need to care lah, but just try lah, in case if they ask for nitrate ion. So if they give you mass already, very easy lah. Okay. Just straight away find number of mole. Okay. Number of mole. 8.88 gram divided by. This one a bit long. No space. Okay. So 8.88. The magnesium nitrate is Mg bracket NO3 bracket 2. So it's 24. Mg is 24 plus 2 big bracket 14 plus 3 times 16. How many? 0.06 mole. So then you use, if you want to find number of particle, in this case you want to find number of particles, number of magnesium ion means number of particle. Okay, so you have to use number of mole multiply the Avogadro constant. Okay, this one. So number of ion, which is 0.06 times 6.02 times 10 to the power of 23. Then I think you will get 3.612 times 10 to the power of 22 unit. So the answer is donkey. If they ask for nitrate ion, then you have to times 2. This number times 2. If it is magnesium, just times 1, then you get the same thing. Okay. #31. Oh, this one is the form for chapter 3 also. The empirical formula calculation, drawing the table. Okay. So what is the empirical formula for metal oxide? If 1.50 gram of X burn completely, 3.2 gram of oxide of X is formed. Okay. So very easy, this one. So draw a table lah. Okay, I'm sure you know how to draw a table. Draw a table. Element. Mass. Number of mole. Then the simplest ratio. Very easy lah. Draw. So X and O. Obviously, you can see it's X and O. Okay, X. Then you got oxide of X means O lah. XO. X is 1.50 gram. O is not 3.2 grams. 3.2 grams is total. Okay. 3.2 grams is the total of X and O. So to use 3.2 minus 1.50, and then I will get 1.7 gram. Then I divide. So number of mole equals to mass over molar mass. 1.50 divided by X is 31. Okay. Then I will get around 0.05. Then for O 1.7 divided by 16, then I will get around 0.1. Then I get around 0.1. So then you divide the smallest number. Okay, the simplest ratio. Okay, so 0.05, which is the smallest number here, divide by 0.05, 0.1 divided by 0.05. So you get 1 and 2. So the formula is XO2. The answer is A. I don't think it's very hard. 32. Diagram 16 shows the pie chart of the percentage of mass composition of fertilizer R. Okay. So, okay, this one is also another form for chapter 3. So fertilizer R is produced from the reaction between HX acid and ammonia gas. What is the mass of ammonia gas needed to produce 17.665 gram of fertilizer R? This one is, you have to use a brain for calculation. Okay. Yeah, so you have to use a brain. So, first of all, write the equation first. First thing, okay? Write the equation first. What's the equation? So they say, what happened? Fertilizers are produced when HX acid and ammonia gas react. So, HX, right? So it means HX, write the equation plus ammonia is NH3. Did it become? And remember, the NH3 can react with H plus to form dative bond to form NH4 plus. X is 1 minus. So this case is NH4. Let's say your fertilizer is NH4X. I don't know what is X, let's say. So and then they ask needed to produce 17.65 gram of fertilizer R. So you know you can start with this calculation first. Okay. 17.665 gram. They ask what? Mass of ammonia gas. Okay, very obvious. The 3 steps, right? So in this case, number 1, find the mole. So number mole of NH4X equals to 17.665, right? 65 divided by NH4X. Okay, so you have to follow this. Okay. You have to follow this. So NH4X, 1N is 14, 4H4 times 1 plus together, X is 35.5. How many you get? 0.33 more. All coordinate, of course. Yeah. For those who might can see this coordinate. For those who know this is HX is HCl, right? But doesn't matter. Okay. So 0.33 more. And then ratio is 1 mole to 1 mole. 1 mole of NH4X to 1 mole of ammonia. And then if you got 0.33 mole of NH4X, then same thing for ammonia. Then we do the same thing lah. Find the mass means mass of ammonia. Just use a number of mole multiply molar mass. Number of mole multiply molar mass, then you get mass. 0.33 multiply 1n is 14, 3h is 3 times 1. So you get 5.61 gram. This calculation can get, so the answer is C. Okay. Any problem in this calculation? Good, good. Okay, and then you have question 33 is from for chapter 6. Okay, so diagram 17 shows a standard solution in a 100 cm cube volumetric flask. And this is to prepare the standard solution. They ask what is the pH value of the solution. Okay, so this one, obviously you have to do. This one very simple only. Okay, so inside contains 0.1 mole per cube of nitric acid. Wow, this one is one of the easiest one. Nitric acid is a monoprotic acid where only produce 1 mole of hydrogen. Sometimes you have to be careful. If they give sulfuric acid, then it's diprotic acid times 2 for the concentration. Don't forget. When you put the pH equals to negative log H plus to find the pH value. Okay, so in this case, she always substitute only. The 0.1, the molarity, just put inside, can get answer. The answer is 1. A. This one just depends whether you remember this formula. Negative log H plus. Straight away 1 mark. This one. Okay. Confirm no 13 or 13. If they give you here is sodium hydroxide solution, yes, you have to minus off. And then if the sodium hydroxide, then here become 13. If it is alkaline, you have to use the POH equals to negative log H OH minus. Then you have to use the pH minus off. At POH, at 40 minus of the POH. Question 34. This one is a little bit involved like a Form 4 chapter 4 theory plus the Form 4 chapter 3. Okay, calculation. So in this case, lithium react, okay, in reaction react with oxygen to form 3.75 grams of solid Z. What is solid Z? Now this one, question 34, I think you need a lot of calculation. So this one it takes around like, if slow people, it takes around 10 minutes. I'm for sure. Okay. So in this case, because you got 2 reactions C, it means calculation both. So in this case, yes, you get lithium oxide. Okay. So when reaction 2 burn with chlorine gas to form, what is solid Y? Yeah, okay. Solid Y is LiCl, lithium chloride. Solid Z is lithium oxide, Li2O. Li is 1 plus from root 1. O is O2 minus. Cl is Cl minus. So they ask what is the mass of solid Y formed when the same mass of lithium is used? Okay. So in this case, the thing you have to find is, of course, the 3.75 is the key, right? So, and write down the equation first. Okay, of course. So, lithium plus oxygen O2, then you get Li2O. Balancing, one oxygen at the right, two oxygen at the left, times 2 for Li2O. 4 lithium, now right side lithium, the left side lithium times 4. And then lithium oxide is 3.75 gram. Okay. So what's the mass of solid Y from? Wow. So it means you have to find this first, lithium first, then you only can find this. So the step a lot. Okay. This calculation takes time, seriously. So that's why I advise normally front part, don't waste too much time. Don't think like don't think like 5 minutes, 10 minutes, think don't. Okay. So save time for this calculation. Uh, don't think you have a lot of time. Okay. If not, you find and waste time, then at the back, then this calculation not enough time. This calculation require a lot of time. Okay. So, 拜拜了，点八哦，calculation you can do, then you cannot do lor. Instead of just wasting time on the front part, better don't. Okay. So, because front part is just theory. You know, then you know. You don't know, then you don't know. Nothing much to say. But this calculation, yeah. So what is? Of course, you find the number of mole per step of the lithium oxide, which is 3.75 gram, the mass, divided by the molar mass. Molar mass is 2 lithium is 2 times 3. 2 times 7, sorry. 7, lithium is 7, am I right? Yes. And then you got oxygen 16. Then you will get 0.125 more. Then you do ratio. Because of course I want to do lithium lah. Okay. I got lithium, then only I got solid Y. So in this case, the ratio is 2 mole of lithium oxide to 4 mole of lithium. 2 times 2 equals 4. So if I got 0.125 mole of lithium oxide, then I got times 2, I will get 0.25 mole of lithium. Okay. Then I can use this 0.25 mole. To find the mass of lithium. Actually, the mass of lithium is not even important. Okay. So it's not to find the mass of lithium. It's not to find the mass of lithium because lithium I don't care. I care about mass of solid Y. Correct. So yeah, I don't even care about the mass of lithium. So I can do this ratio to the lithium. Correct. How? Of course, you write the equation first, right? So the equation is, another equation is lithium plus chlorine. Then I will get LiCl. This is my key, right? Lithium chloride is my key. So then you balancing times 2 times 2 lah. Okay, any still don't answer balancing, ask me lah. Okay, until now I hope you understand balancing already. Before arrow, after arrow, the amount of substance must be equal. Okay, and then now you can do ratio. Since the ratio, I got 2 mole of lithium to 2 mole of lithium chloride. So just now I get what? 0.25, right? 0.25 mole of lithium. Then also I will get 0.25 because 2 to 2 means 1 to 1. Yes, you have to check first. Then only I can use this 0.25, multiply the molar mass to get the mass of chloride, lithium chloride. Okay, so the mass of lithium chloride is 0.25 multiply lithium is 7, chlorine is 35.5. Means the number of mole multiply the molar mass. Easily you get 10.0625 gram. The answer is B. Yeah, this one take a bit of time. I don't think it needs 10 minutes, but 5 minutes. I say 5 minutes. All the back to calculation. So 35 is from 5 chapter 1 calculation. The following ionic equation represents a redox reaction. Okay. So 2xO4 minus, okay, plus 16H plus 10Br minus to get 2x2 plus 8H2O 5Br2. Okay, this one is the ionic equation actually. I don't know which one, okay, but the ionic equation that you can see contain Br2. Okay. So what is the change of oxidation number of X in the reaction? Oh, so in this case, you know, okay, very simple. So you can see this is positive 2. So of course, in the end must have positive 2. Okay, X2 plus means positive 2. Then come to this one. Yeah, it's very easy. Okay, so very easy one, this one. See, this one you got one negative. See properly. So it means, hey, the 2 don't care. The big 2 don't care. The number balancing don't care. Okay, we ignore. We take this thing on it. The number balancing don't care one. Nobody cares. Okay, so it means XO4 negative. X don't know, right? You know O always negative 2 one. O2 minus my negative 2. So you know, but here got 4O. So 4 times plus 4 times negative 2. Overall, what is the charge? What is the charge? Negative 1. 1 negative is negative 1. So you can get the answer here. So simple. Okay, mathematics. 4 times negative 2, negative 8. Negative 8 move the other side, positive 8. It means your X is positive 7. So the answer should be B. Very straightforward. From positive 7 to positive 2. Okay. 36 is Form 5 Chapter 3 calculation. Okay. Diagram 19 shows the diagram of the breakage and formation of bonds in a reaction. Okay. So this one is the energy profile diagram that show you where X2 plus Y2 become 2XY. This is the activation energy. Okay. And you can see actually okay, the energy, you see the energy ending. From less energy become more energy. Okay, the total energy reactant is lower than product. So you know this this is endo. Okay, this is endothermic. The exothermic is the balik. I show you. Okay, this is endo. Sorry, this is exo. This is endo. Just look at yourself the difference. Okay. So in this case, the table 3 shows the chemical bond energy for 3 bonds. Okay. What is the value of Z? Okay. So in this case, wow, this one. I should teach in physics class. Okay, I forgot about this question. Yeah, I should teach in physics class. Okay. So this one is like this. Okay, this part bond energy. Okay, you see X2 plus Y2. Okay, so they told you one XX bond is 160 kilojoule per mole. Okay, and here we only got one. So correct this is 160. The YY bond, Y2 is the YY bond, right? YY bond is 204. is a 204. Okay. So in this case, it means you add together these two. You add together 160 plus 204, then you will get 364. You will get 364. Okay. So in this case, and then how about the product? The product have two xy. It means it has two xy bond. Okay. So two xy bond. This one is one. One xy bond is 201. It means you got 2 means 2 times 201. Then you will get 402 kilojoule per mole. Okay. This one is 364 at the reactant. Okay. So in this case, yes, you have to use okay, the heat of reaction. The heat of reaction, the delta H, you have to use the product minus the reactant. Minus the reactant. Yeah. So it means 402 minus 364. Then you will get positive 38 kilojoule per mole. So in this case is B. Yeah, this shows that it shows that this is endo. Okay, shows that this is endo. If you don't know how to analyze the diagram, the formula is heat of reaction is equals to heat delta H product minus delta H reactant. Yeah. The bond, if they give you like this, they give you one bond, how much energy? But 2xy means you do times 2. Yeah, this question I should have done in physics class, but I think that time not enough time. Okay, so you got question 37. What is the field value? This one is also from 533. What is the field value for butan 1O? Oh, okay. So if the heat of combustion of butan 1O is negative 2675 kilojoule per mole. Yeah. Oh, but I forgot to tell you, okay, just now, sometimes they won't give you the proper diagram. So you have to know yourself. Okay. If they don't give proper, then you have to know the formula, this one. H product minus the H delta H reactant. Then you can get the difference. Yeah. Sorry if I forgot to tell. Okay, this part. So a bit tricky. Okay, not so tricky, but you know, objective 可以看到 any question. Okay, doesn't matter which one. So it's in the syllabus actually, but it's a bit rare. So this one field value formula. Field value equals to heat of combustion, the delta H. Okay, let's show you delta H. Okay, which is the heat of combustion divided by molar mass. The delta H contain kilojoule per mole. Molar mass contain gram per mole. So it means mole negative 1 cancel off. Then you can get the unit for P value is kilojoule per gram. Kilojoule per gram. So it means you straight away use 2675 divide the molar mass for butan. Now, what is formula for butan 1O? If you don't know, cannot do. How to find molar mass? Ayo, B means 4 carbon. Told you already, man, this is 4 carbon. Butanol is alcohol, of course lah. Okay, so it's CnH2n plus 1 OH. But means 4 carbon. C equals to 4, N equals 4. What's the formula? Ayo. C equals to 4, N equals 4. C4, H9, OH. What H8 or H9? Ơi. What H8? What H5? Ui. 2n plus 1, mister. 2 times 4 plus 1 is 9. Ay, yo, yo. Why ni? Cannot, GG. That's why some, even chapter 3, how to say? It also involve how much chapter 2 knowledge. Yeah. Yeah. Didn't see one. CnH2n plus 1 OH. Okay. C4H9OH. So 4 times 12 plus 9 times 1 plus 16 plus 1. What's the answer? uh, 36.15 kilojoule per gram. So answer is donkey. Oh, this part cannot. GG. Field value. Okay. Ayo, my chapter 2. Yo. Yo. You see, it can be trouble if it's no chapter. This chapter is white. Okay. Okay. Question 38. This one is another form 5 chapter 3 calculation. So this one is the delta H equals to MC equals to Q per mole. Yeah, the double decomposition reaction, yes, the heat of precipitation. Heat of precipitation. Okay, where you get the white precipitate, which is the barium sulfate, the white precipitate, the insoluble salt. Okay, so they ask, the important is not this one, the important is what is the mass of precipitate form? Yes, the precipitate important. When 100 cm³ of each solution is added and the temperature increases by 3 degrees Celsius, then they give you, of course, the specific heat capacity, 4.2, all this. Okay. So what's the first step? What's the first step? I do here. Okay, I do here. Question 38. Ui, sorry. Do here. Okay, so the first step is first step, Q equals to mc theta. What is mass of water? How much? It's not only 100, mister. Okay, and miss. Normally, yes, okay. Each solution, and remember, this one is both soluble salt. They say each one contain 100 cm³. Student always mess up this one. Okay, so very normal. Okay, so each solution means each is 100. Mixed together become 200. So your M is 100 plus 100. C is specific capacity, always fixed 4.2. Theta, 3. Very simple. Okay. How many? 4.2 times 3, 12.6. 12.6 times 200. 2520. Am I right? I use my head to count. I don't know. Okay. Correct, correct, correct. Don't agree with me. Then you find number of mole, which is MV over 1000. A what they find? Oh, they didn't ask for delta H. Interestingly, they asked for the mass of precipitate. Oh, okay. So in this case, it means you cannot use MV over 1000 because they didn't give you the molarity. So yes, Correct lah, correct lah. You have to use delta H equals to Q per mole. Yeah, because the M don't have. So you can use this one. Terbalik. Okay, they give you delta H. Okay. So it means if you want to find mole, okay, if you find mole, then only you can find the mass. Yeah, so if you want to find mole, then you use delta H. Wait, no, Q divided by delta H. Yeah, Q divided by delta H. So it means 2520. No, not divided by 1000. Okay. If you want to find mole, you see, you want to find what? Mass of barium sulfate. Okay, so of course you have to get number of mole, then only you can times molar mass, then only you can get mass. So you have to get the number of mole first. I can use this formula to get number of mole because I got delta H because I calculated Q just now. So I use 2520 divided by, don't forget, 42 kilo means 42000. How many? Oh, you mean change joule to kilojoule? Okay, whatever lah. Okay, so it is true. Okay, but you can just change this 42 kilo to 42000. Then you just divide. Yeah, don't forget the kilo. Kilo. Okay, you will get 0.06 mole. Then only uh okay, since the ratio is all a 1, 1, 1, so doesn't matter already. All are 0.06 mole. And then that's why you use 0. Okay, if you want to find the mass of barium sulfate, then you use 0.06 mole multiply the molar mass. Molar mass is 1 barium is 137. 1 sulfur is 32. 4 oxygen, 4 times 16. This question also a bit tricky if you don't know how to do. Okay. Yeah, so of course, okay, I give you the formula, then you very happy. Okay, but even just now I think a little bit. I need time, I need the time to think a little bit what I want to find. Okay, so I think you get answer right? 13.98 gram. Am I right? Donkey. What do you think about this calculation? And like try to think how much time you have for exam. Okay, okay, you think exam got time? I don't know. Better than chapter 2. Okay, so question 29 is a form 4 chapter 7. Okay, which this paper is a bit rare in paper 1. Okay, so diagram 20 shows the apparatus setup, okay, and the observations of 2 experiments that had been carried out in the lab. Okay, so they use time, how much time needed to collect 50 cm³ of gas R. Okay, so you can see they added solid Q into the hydrochloric acid. Okay, set 1 is X mole per dm cube, set Y is Y mole per dm cube. Then the temperature both same, 30 degrees Celsius. Before that, of course, you start with 0 second. Okay. After that, okay, how much time needed to collect 50 cm³ for experiment 1 is, I don't know how many seconds this one, okay, but okay less than 30 seconds, okay, but you know set 2 is 30 seconds, maybe set 1, I don't know, I don't know how many seconds, don't have the time properly, so it means, of course, this one requires shorter time, means set 1 requires shorter time means higher rate of reaction. Set 1 higher rate of reaction, set 2 lower rate of reaction. Okay, and then okay, what happens is Okay, like this one, right, most probably the difference is the concentration, right? Most probably is the different molarity, different concentration of the acid. But they told you experiment 3, okay, is carried out by repeating the experiment 1 with solid Q that is crushed, okay, that is crushed means what? Means become smaller size, okay. Crushed means become smaller size, like you crush, let's say you crush your candy, you crush into smaller pieces, okay, and the temperature is double. Okay, so which of the following graph sketches represent the three experiments? Wow. Uh, so I have to check lah. Okay, so in this case, now you see different concentration X and Y, and I told you right before. Okay, even in booster class. Okay, so if you change the concentration, the ending of the graph different. Okay, what does it mean by ending of the graph? You see, like you see, like graph like A, right? All the endings same. Okay, like you see B 1 and 3 ending same. Okay, so but the problem is if you don't change the concentration, yes, all the ending will be same. Volume of gas will be same. Okay, it's just that uses how much time will be different. Uses how much time will be different. Okay, but if they change the concentration, just remember, if you change the concentration, then the volume of gas will be double. Let's say if the concentration, of course, if the higher rate of reaction means the concentration is double, right? So the volume of gas also 2V. This one is V. Okay, so it means I want to see that curve 2 is lower, ending lower, like this. Okay, something like this. Okay, then curve 1 is like this. Something like this, right? So the curve 1 is curve 2. Ending different, the time usage also different. Of course, the first one will be faster lah. Okay, so and then they ask for set 3 also. Wow. Okay, so set 3 is the same as set 1. It means you see, the concentration is same as set 1. So it means the set 3 ending also should be here. But because of the size factor, which will be even faster than this set 1, because smaller size, because temperature double. So of course, it will be something like this. That the blue one is set 3. Okay, so you look at which one is similar. So for A already out, because time, right? Because of the set 2 changes constant. The set 2 and set 1 have different concentration. That's why the ending will be different. Okay, so the answer should be correct. You see properly, the thing that I draw is B. I don't answer the graph, you ask me. So this one require brain thinking. Okay, if not familiar. Just that, because set 1 and set 3 didn't change the concentration. Set 3 changed the size and the temperature. They saw the ending should be the same between 1 and 3. 2 will be different. 2 will be different. Okay. Can. Question 40. This is Form 4 Chapter 6 salt analysis cation test. This one is really cation test. Okay. So, and then look at set 1. Okay. If you got XCl2, white solid, okay, add water, then you heat you heat the HCl2, okay? Then after 5 minutes, you will get white solid. Okay. So in this case, white, okay, this one very easy actually. If you know, very easy already. So white, it's not a cat and test, so okay, not a cat and test. Okay. So white solid of Xi2, when you heat, you will get color solution. After 5 minutes, you will get yellow solid. You know what is X? Okay lah. Okay. Since people know that. But the formula is wrong. It's not PBI, PBI2. Okay. But anyway, okay. Yes. This is PbCl2. This is PbI2. Yeah, PbI2 is yellow solid. Correct. Okay. Yellow solid. PbCl2 is white solid. Okay. You know what happened? Because there's a rule. Actually, PbCl2 and PbI2 both are insoluble salt. Okay. Both are insoluble salt. Let's say at the beginning. Yeah. It means PbCl2 white, PbI2 yellow. Okay, both are insoluble salt. It's just that, okay, insoluble in room temperature in cold water. Okay, but unless you heat, if you heat, then the precipitate disappear. Yes, okay. Then it is actually soluble in hot water. After you cool down, then the precipitate will come back again. So this is only applied to the Pb, the lead-2 ion. So the answer for X is C, lead. Okay.